625 meters above a river, suspended over a canyon that swallows sound. This is the world's highest bridge, and China just built it. The impossible divide. The Huajiang Grand Canyon, carved by millions of years of erosion, 500 meters deep, 2 kilometers wide at points, sheer limestone cliffs dropping straight into mist for centuries, crossing meant a 2-hour journey around the gorge, dangerous mountain roads, isolated communities on either side, no direct connection possible, until engineers decided to do the impossible, build a suspension bridge higher than any structure humans had ever suspended over Earth, taller than the Eiffel Tower, higher than clouds, at an altitude where commercial jets cruise. The goal: connect 2 provinces, slash travel time from 2 hours to 2 minutes, transform regional economics overnight. The challenge: physics, weather, and a canyon that seemed designed to reject human engineering. The numbers that shouldn't work. Bridge deck height, 625 meters above the river. World record. Main span, 1,420 meters. Longer than 12 football fields suspended in air. Total length, 2,890 meters. Nearly 2 miles of roadway floating over nothing. Steel used, 40,000 tons, equivalent to 5 Eiffel Towers. Cable diameter, main cables nearly 1 meter thick, each containing thousands of individual steel wires twisted together. Construction timeline, 5 years. Completed September 2025. Cost, $300 million. But the economic impact? Billions. Why suspension bridge design? Because cable-stayed bridges couldn't span the distance. Arch bridges couldn't reach the required height. Suspension was the only physics that worked. 2 massive cables draped over towers. Vertical hangers dropping down. Steel decks suspended from those hangers. Simple in concept, extraordinarily complex in execution. Anchoring into mountains. Before building up, they had to dig down. Gravity anchors, massive concrete blocks buried deep in canyon walls. These hold the main cables, preventing the bridge from being ripped from the earth. Excavation began by carving into solid limestone. Thousands of tons of rock removed, creating anchor chambers larger than buildings. Steel reinforcement cages assembled. Thousands of individual rebar pieces hand-tied together. No room for weakness. Then the pour. Continuous concrete flow for days. Vibrators eliminate air pockets. Any weakness becomes catastrophic failure. The concrete cures into artificial bedrock, heavier than the tension trying to pull it free. Physics balanced against physics. Tower foundations next. Different challenge. Must support vertical weight while resisting horizontal wind forces. Deep caissons sunk into canyon walls. Uneven terrain means uneven tower heights. One tower 239 meters, the other 247 meters. Perfectly calculated for cable geometry. No margin for error. Towers rising into clouds. Construction method: hydraulic climbing formwork. Pour concrete. Let cure. Climb form higher. Repeat. Week after week. Month after month. Towers growing meter by meter toward sky. At this altitude, wind becomes enemy. Gusts strong enough to halt construction. Workers operating in conditions commercial pilots avoid. Temperature swings extreme. Blazing sun to freezing fog within hours. Concrete curing must account for thermal expansion. The towers flex by design. Rigid structures snap. Flexible structures survive. Engineering dancing with physics. Saddles installed at tower tops. Perfectly machined to guide cables. Millimeter precision required. These contact points carry entire bridge weight. When complete, twin towers stand like sentinels, visible from dozens of kilometers away, monuments before the bridge even exists. The first connection. Now comes the moment that makes or breaks the project. Connecting 2 sides separated by nothing but air. A drone carries the pilot rope. Simple technology solving impossible problem. First physical link between canyon walls. The rope weighs almost nothing, but it pulls everything else. Pilot rope pulls thicker rope. Thicker rope pulls cable. Cable pulls heavier cable. Step by step, building strength to support the catwalk. The catwalk, temporary bridge for workers. Mesh platform suspended hundreds of meters above river, where construction happens. Takes courage walking where birds hesitate. Once catwalk complete, cable spinning begins. Thousands of trips back and forth, carrying individual steel wires. Building the main cable strand by strand. Workers bundle wires into perfect geometric patterns. Order determines strength. Chaos means failure. Compactors squeeze the bundle into circular cross-section, wrapped against corrosion, sealed against elements. These cables can hold aircraft carrier weight. They'll hold a highway. Deck assembly in the sky. Steel truss segments fabricated below, each section pre-assembled, tested, numbered, ready for installation. Cable cranes move into position, purpose-built for this exact task, running on the main cables themselves. Test lifts using dead weight. Sensors monitoring cable tension real-time. Any unexpected behavior stops everything. Smart technology embedded throughout. Fiber optic sensors, strain gauges, temperature monitors. The bridge will self-monitor for its entire lifespan. First deck segment arrives. The crane descends, hooks attach, lift begins. Slow ascent into sky, hundreds of tons rising through air, wind pushing, cables swaying, precision required. Segment meets suspension level. Workers guide it into position, pin it to vertical hangers, bolt it to previous section. First piece in place. Now repeat. Again and again. Segment by segment. Gap closing from both sides and from center. Beidou GPS ensures millimeter accuracy. Chinese satellite navigation guiding assembly in real time. Welding joins segments into continuous structure. Zipper of steel closing canyon. The closure moment. Final gap remaining. The closure segment, keystone of the entire structure. Temperature affects steel length. Installation window measured in hours. Too hot or too cold and fit becomes impossible. Engineers wait for perfect conditions. Moment arrives. Final segment lifted, positioned, measured, perfect alignment. Bolts driven, welds completed, canyon conquered, bridge becomes one. Longest mountainous suspension span complete, finishing the highway. Steel reinforcement laid across deck, preparing for traffic loads. Concrete poured, creating smooth, stable surface, perfectly level across entire span. Temporary catwalks removed, no longer needed. Anti-corrosion paint applied to all steel. Protection for decades of exposure. Final asphalt layer laid. Road surface smooth and durable. Safety barriers installed. Crash tested for maximum impact resistance. Lane markings painted. Highway taking final form. Lighting systems activated. Transforming bridge into nighttime sculpture. September 2025, load testing begins. Trucks loaded with maximum weight. Monitoring every structural response. Confirming calculations. Bridge passes perfectly. The transformation. Highway opens. 2-hour journey becomes 2 minutes. Villages once isolated now connected. Economic impact immediate. Goods moving faster. Tourism exploding. Regional development accelerating. But China didn't stop at transportation. Glass elevator installed. Descends into canyon for tourists. Viewing platform at mid-height. Skycaf built into tower. Dining hundreds of meters above river. Glass walkway inside truss structure. Walking through the bridge skeleton itself. World's highest bungee jump. For those seeking ultimate thrill. Nighttime light show. Waterfall effects on cables. Engineering marvel becomes tourist destination. At night, the Huajiang Grand Canyon Bridge transforms. Lights trace the cables. Deck glows against darkness. Clouds drift through the spans. 625 meters high. 1,420-meter main span. World records that redefined possible. $300 million. 5 years construction. 40,000 tons of steel. But the real achievement isn't the numbers. It's the moment engineers looked at nature's greatest barrier and decided to connect it anyway. The Huajiang Grand Canyon Bridge, where humans briefly learned to touch the sky.